Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 7, Chemical Foundations Part 7. This is the last video of Chapter 1. We're going to be talking about all the different types of matter and how we classify them in this video. Some of this will be a review for you, so it will be a lot of content in a pretty short video relative to the amount of content. Pause here. So this should be a review for you. You've seen solids, liquids, and gases since you were a small child, I would sure hope. And I've listed them in order of increasing energy. I'm just going to say the transitions out loud. If you don't already know what they are, I would suggest writing them down. I do expect for you to be familiar with them. Solid to liquid is melting. Solid to gas is sublimation. Liquid to gas is either evaporation or boiling. We'll discuss in class the difference between the two. Gas to liquid is condensation, liquid to solid is freezing, and gas to solid is deposition. If you go up in energy, it's going to be endothermic, and if you go down in energy, it's going to be exothermic. Pause here. I'm going to wait about 10 seconds and then say the answer out loud. Melting is endothermic. You have to add heat to make that happen. Subliming is also endothermic because you have to add heat to make that happen, whereas condensing is exothermic. This releases heat. Pause here. So we're going to break down matter into two basic categories, mixtures and pure substances, and then we'll have subcategories from there. So pure substances, they consist of one type of atom or one type of molecule. So these could be elements, these could be compounds, these could be atoms or molecules. But the important thing is whatever the smallest unit is, that is the only thing that is in there. As opposed to mixtures. Mixtures are physical combinations, meaning that they're not bonds haven't broken or formed, of two or more elements or compounds, or combination of the two. And we can separate these into two categories. The first being homogeneous mixtures. So these are things that are uniform throughout. These can be separated using distillation or chromatography. We'll talk more about what those are during class. And then heterogeneous mixtures. These are not uniform throughout. These are separated using filtration. Another way to think about it is with a homogeneous mixture, if you were to take it under a microscope, you likely wouldn't see the different components, whereas a heterogeneous, you would. Pause here. And these sort of go with the types of mixtures as well, physical versus chemical changes. Physical changes, these are changes in state. So when you have distillation, for example, you're taking advantage of a physical change in order to separate a mixture. Whereas chemical changes, these are changes in composition, you creating something that wasn't there before. These are irreversible without another chemical reaction. Pause here. I'll say the answer out loud in about 10 seconds. I'll also give an explanation of them. Orange juice is a heterogeneous mixture. Things that are biological in nature, meaning something like from a plant or an animal, are usually going to be heterogeneous. You could separate these using filtration. If you were to put orange juice with a filter, you would have some sort of orange junk in the filter. The second, gasoline, that is a homogeneous mixture. This is separated using distillation. C is a heterogeneous mixture. Again, it's a biological mixture. It's coming from a cow. D is pure water. That is going to be a pure substance if it's just pure H2O. Tap water is usually a homogeneous mixture. There's dissolved gases, hence why fish are able to breathe. There's dissolved CO2, dissolved O2. Then salad dressing is a heterogeneous mixture. You're able to separate it using filtration. Thank you so much for watching and have a great night.